The show that reveals how extraordinary items in our world are designed, constructed and produced. See the engineering, the technology and big ideas that make the world go round. Find out how it works. Coming up in today's show, you'll be riveted to your seat with our step-by-step guide to the high-tech hiking boot. We'll explain the production process and electrifying technology behind the tool with the toughest grip, the humble wall plug. And if you've ever wondered what happens to the hand towels that run out, then stick around and watch as the story unrolls before your eyes. But first, we've all seen them, young people partying out of the roof of very long American cars. Limousines are often associated with superstars, but when savvy entrepreneurs saw an opportunity, a new industry was born. Everything from a Cadillac to an SUV can be transformed into an extra long limo. And here in California is a factory that specializes in doing just that. To convert a car into a limousine, first you need to strip it. Many standard parts have to be replaced so they can withstand far higher workloads. Once they're left with the empty shell, the mechanics can start cutting. There's no dedicated stretching tool, the process is very simple. They just slice the car straight in half. To ensure the car keeps its structural integrity, they have to cut along the framework. Once they've got two halves, the mechanics simply weld an extension between the original front and back. The car can now be stretched by almost 3 meters. This sort of limousine would be aimed at wealthy customers. Party limos are more extreme. In America, cars can be stretched up to 13 meters, but they would have difficulty navigating around many European cities. For the proper party limo, the company will stretch a vehicle an extra 5 meters, but it has to be properly rebuilt to pass road safety laws. These mechanics will use 18 large steel bars to reconstruct the frame. Using a simple piece of string helps the mechanic to get everything lined up properly. If the car's frame wasn't true, it wouldn't drive in a straight line. The next mechanic can assemble the new floor. This will be welded onto the frame so the interior can be fitted out. Vertical sidebars are installed too, but they have to sit perfectly for obvious reasons. So far, the mechanics have rebuilt the new limo skeleton. The panels come next with a fresh coat of paint and hand-rubbed wax. Limos are impressive pieces of engineering, but they're far bigger than originally intended. The heavier structure plus the additional passengers means the components will need to be upgraded, starting with brakes and the suspension. With new larger discs fitted, the mechanic opens up boxes of brand new springs. They are capable of supporting far higher loads than the original system that is supplied with the car as standard. The bigger the limo, the tougher the suspension needs to be. And the same goes for the windows, which take 3 men to carry. To achieve that extended look, the windows ideally are made out of one piece of glass, but sometimes that just isn't possible. Wooden floors are fitted because they're easier to clean than carpet. And then there's the seating. The original chairs will be sold. To get lots of people inside this car having a blast, bar-style seating is the order of the day. Big benches are custom made for each new vehicle. Then they're installed by hand, which is a tricky business, even with 3 guys helping out. And what party limo could roll along Sunset Strip without the all-important bar? It's fitted neatly into the pre-cut space in the floor and wired up. The modern limousine is full of luxury gadgets such as TVs, DVD players and stereo for the guests' entertainment. Some models even feature disco lighting for that real party atmosphere. However, all these gadgets mean a bigger drain on the battery. The mechanics installed 2 extra dynamos to take care of the increased power demand. But there's one power demand that is a constant with all cars. No matter how long they are, that petrol tank always needs to be filled. This SUV with all the conversions takes 39 litres of fuel to do just 100 kilometres. It's a real gas guzzler. So what started out as your ordinary sports utility vehicle has been transformed into one of the longest cars on the road today. And although you wouldn't be able to take this 4x4 off-road anymore, it can certainly handle the highs and lows of downtown Hollywood. The stretched limousine. A walk in the country is the best way to get some fresh air. But if you're hiking in the wrong footwear, wet feet, blisters and potentially serious injuries could result. So what's the solution? One answer is a pair of top-of-the-range hiking boots. From the initial drawings, a designer will use his templates to create a shape and style that both look good and support the wearer's foot. Once it's been approved, the production plant can get to work. The first step is material selection. The boots are made of leather for its strength, but each skin is different, so choosing the right raw material is important. Once the right hides are selected, the tailor starts cutting out the shapes he needs. These boots use over 110 different pieces of leather, cloth and metal in all. They're designed to take a lot of strain, but despite their strength, they also have a softer side to them. Inside the boot's tongue is a sophisticated breathing system to help keep the hiker's feet cool. Steam is collected in the boot's tongue and the walking action pumps it out through tiny holes on its surface. This lets the sweat out without letting water in. The secret is Gore-Tex. Water molecules are 20,000 times bigger than the air holes, so water won't flow into the tongue. However, steam molecules are 700 times smaller, so it can escape. It's a one-way system to help keep the feet dry. Tests are run on samples of the Gore-Tex inners to make sure they're well made and watertight. Rivets and eye hooks for the laces are fitted with a custom press, and the upper part of the shoe is now nearing completion. As well as protection from the elements, the shoe needs to be comfortable to wear, so this internal support is included. With the upper section fully constructed, the boot can now be given its characteristic shape. Waterproofing and strength are the most important elements for this bit of the shoe, so it's vital that the seal is solid. First, this robotic device clamps the upper into the shape of the human foot and holds it. The lower portion is then put into place and released. Now, walking in boots like this wouldn't get you very far, as they would fall apart very quickly. But this layer of glue will help waterproof the boot as well as sealing it. A second layer of glue is added for extra protection, and the boots are now ready for a trip in the heating tunnel. This helps seal everything together properly. Next, this operator will add a rubber layer around the bottom of the shoe. This extra protection makes the company so sure it will keep the wearer's foot dry, they can actually guarantee it. To maintain this high standard, the company regularly tests their product. They're put in this tank and left for 7 days, during which time they'll be forced to take over 300,000 steps. If they're let in 1 drop of water, they fail. These test conditions mimic the kind of wear and tear they'd experience in real life, but the next test quite literally pours on the pressure. Yes, the tester is filling the boots with water. He will then place them into a centrifugal machine which will spin them at 240 revolutions per minute. This is designed to simulate up to 10 times normal pressure on the seams and joints of the boot. This tests whether they really will take the strain. Any leaks, and it's a fail. The final stage of putting the boot together is the sole. This must grip in even the trickiest of conditions. 44% of the adult population in Britain say they walk for leisure. It's a very popular pastime, and safety is a concern for any serious rambler. With construction complete, the staff can now add the finishing touches to get the boots ready. Rubber is smoothed and polished clean, hanging threads are burned off with a lighter, and a quick layer of leather protection is sprayed on. All that remains is for them to be laced up before they can get to work. Each year, this factory alone uses over 2.5 million meters of laces to help keep their boots on their customers' feet. And they're ready to go. They'll only spend a short time in the box before a rambler will buy himself a pair and then march straight to the top of the nearest mountain. And while even the most hardened hiker needs a break, a good pair of boots should last for a long time. Still to come, there's more technology behind the tiny wall plug than you'd probably imagine. We reveal the shocking truth. And it's a non-stop job for the company on a roll, ensuring that hygiene isn't going down the pan in our public toilets. Getting to grips with decorating your home can be a tricky business. Take mounting a picture, for example. The average concrete wall doesn't take too kindly to ordinary nails, but with the right bit of equipment, the job is simple. The wall plug revolutionized wall hanging. In 1919, British inventor John Rawlings hit on a novel idea that would help attach things to walls, and today they're used all over the world. The original wall plugs were made out of brass, fibre and string, but today's are made out of plastic. It's transported to massive production plants in big tankers like this one. It may surprise you to learn that these tiny plastic beads are made out of the same material as stockings. That's right, it's nylon. There are a huge variety of wall plugs on offer today to suit different jobs, materials and loads. And it's factories like this one that are the heart of the production process. Each of these tubes brings the raw nylon granules to the machine so they can be melted down and turned into the plugs. The system uses injection molding to squeeze the molten nylon into the right shaped cavity. Once it's cooled to the desired shape, it can then be removed. Each type of plug needs its own unique mold. When the machine is closed and the liquid nylon is poured in, these bars will be inserted. This forces the nylon into the spaces around the edges. The bar creates the hole the screw will eventually fit into. Making molds for these machines is a time-consuming process and can take up to 4 months to complete. This engineer is carving copper templates. They'll be used to make a new mould for the wall plug production machines. The copper model is carefully lowered into a petroleum bath along with the steel mould plate. A switch is flicked and a massive 380 volts of electric current pass into the copper plug. This cuts the right-shaped hole into the steel plate. This mould plate can now be installed in any one of the 50 machines making wall plugs. Liquid plastic will be forced in, and when it's cooled, new wall plugs can be removed. Each of these machines can produce around 300,000 every day. The new plugs need to be separated from the framework they're made on. The plugs themselves fall onto a conveyor belt and are carried off to the packing facility. Designing new wall plugs is a complex process. The engineers will use high-tech graphic software and computer animation. This helps them analyze how the plug will experience the stresses of supporting heavy objects. The original plugs developed by John Rawlings were a cylinder of fibre for the screw to grip. Modern designs have a variety of flanges and elements that help grip the surrounding wall. Laboratory tests show the difference that one small change can make. This is the new wall plug with 4 expanding elements. The white one is the old style with just 2. Let's see how they cope. Each plug must lift a washing machine weighing over 280 kilograms. The old style white plug is first. Tensions rise as the block takes up the slack, but nothing's rising and the plug slips straight out. Next comes the new design, which seems to work effortlessly. The washing machine and frame with all its weight lifts off the ground and remains suspended. The trick is simple. On the right we have the new 4-bladed design. This puts full surfaces in contact with the wall. That's double the contact and therefore gripping power of the old 2-bladed model on the left. That extra grip is the secret behind these tiny plastic helpers. With hundreds of thousands of plugs pouring off the production line every day, all that remains is for them to be boxed up and sent out to the waiting customers. This machine carefully weighs up the right amount, then sends them onto the preformed boxes below. But this initial weighing process isn't perfectly precise, and some boxes don't get enough plugs in them. But the next device takes care of that. By weighing them again, the machine can determine which boxes have the right amount of plugs inside. Any half-filled boxes are rejected, while the rest are sent out to the customers. It's the gripping tale of the simple but effective wall plug. It's the age-old dilemma you face when you wash your hands in a public toilet. If you use the towel, it's probably not very clean. The electric dryer never seems to do the job. One of the best solutions is the roller towel dispenser. Fresh, hygienic towel for each new user and it does the job. But what if the towel runs out? At that point, the maintenance man from the towel dispenser company arrives and collects the old dirty towel to take it back to the plant. 15,000 towels are brought from all over the country to an enormous facility like this one every day. Here, they will be refreshed. First things first, each dirty towel is still rolled up and they need to be completely unraveled to be washed. The rolls are pulled out and then laid out neatly. This way the soap can reach all of the towel. To stop several getting tangled up in the wash, each one is now cable tied. It will join hundreds of others ready to be sent to the washing machines. When the next machine is ready, the bucket is opened. However, like children who don't want a bath, they seem a bit reluctant to get in, but the water pressure mounts up and eventually forces them inside. At 90 degrees Celsius, this machine uses just 4 grams of washing powder for every kilo of towels. It can rinse through about 1,000 every hour, a bit more efficient than your machine at home. Now for the drying. First, they're crushed. This removes all of the water. The enormous pill-like block that emerges is dry, but it's also solid as a rock. The next machine takes care of that though. The disc of clean towels is spun and loosened, which separates them once more. The factory now has hundreds of meters of clean but wrinkly towels. It's time to roll them back up again. The cable ties are cut and the towels are fitted to the next machine, which unravels them. Next, they will be fitted to this device. It's vital for one important reason. It makes sure the towel isn't twisted, which would jam the machines. Using an imaginary line seen here in red, a computer watches the towel as it passes. If the towel crosses this line, the device tugs a bit, which straightens it out, helping to avoid unwanted jams. Now the towels can be re-rolled using vacuum power. The holes in this device are connected to a pump which sucks air into them. When a towel passes over it, it gets sucked onto the holes, and as the bar spins, the towel is then rolled around it. A sticker is applied telling the staff that it's clean and ready to go. They are then reloaded into the cage, ready to refill towel dispensers all over the country. Each towel has a lifespan of about 100 washes, but damage can occur at any time during that period. If a damaged one appears, the operator will mark this towel and it will be sent to a different department. Here it will be repaired or turned into cleaning cloths. With a cage full of fresh towels, the maintenance man will load it back up into his van and head back out to refill the dispensers on his route. The sticker showing it's a fresh new towel is removed and it's reinserted into the machine. Now instead of wiping your hands drying your trousers, you've got a clean, hygienic towel ready to dry them for you.